This question says, consider the reaction below. The reaction begins with only CO2 at 1.2 molar, and the equilibrium constant Kc is 8.30 times 10 to the minus 6. There's an extra minus in there, and that should just be minus 6. And it says, what is the equilibrium concentration of H plus and CO3 to HCO3 minus? So hydrogen ion or a proton and bicarbonate. So this is very, very similar to the previous question. So what we need to do is first write the expression for Kc. So Kc equals products over reactants. In this case, concentration of H plus, concentration of HCO3 minus bicarbonate over concentration of CO2. Note that water is not in here because water is a liquid and its concentration is constant because its density is constant essentially. So let's look at this. Well, what we want to do is use an ice table, initial, change, and equilibrium. And everything that's in the Kc expression should be in the ice table. So the concentration of CO2 in molar, the concentration of H plus in molar, and the concentration of HCO3 minus molar. Initially, we know that the CO2 is 1.20 molar. And we know that H plus and HCO3 minus are both 0 because the reaction begins with only a concentration of CO2 of 1.2 molar. So we don't have any H plus or HCO3 minus. What about the change? Well, we're going to add X amount, we don't know, we're going to add X amount of H plus and HCO3 minus. And we're going to subtract X amount of CO2. So what we end up with is, for equilibrium concentration, as 1.20 minus X of CO2, X of H plus, and X of HCO3 minus. We are again going to make the assumption that we can ignore X so that we don't have to use the quadratic equation. And the rule is if X is less than 5%, then we're good. So let's plug in our values that we know. Well, we know Kc, it's given in the problem. 8.30 times 10 to the minus 6 equals concentration of H plus at equilibrium is X. The concentration of HCO3 minus at equilibrium is another X. And we're going to ignore X here, so the concentration of CO2 is just 1.20. Cross multiply, and I'm going to go up here. X squared equals 8.30 times 10 to the minus 6 times 1.2. And you're going to get 9.96 times 10 to the minus 6. So we took 8.30 times 10 to the minus 6 times 1.2 and got 9.96 times 10 to the minus 6. Take the square root and only consider the positive answer. And we get X equals 3.16 times 10 to the minus 3 molar, which means the concentration of H plus equals the concentration of HCO3 minus equals 3.16 times 10 to the minus 3 molar. So these are the equilibrium concentrations. If we also notice, this is 1.2, this is 3.16 times 10 to the minus 3, this is like 0.3%, a little bit, not exactly that, a little bit less than that, of this one. So it's not even close to 5%. So we're good, and ignoring X was the right thing to do. Again, on the exams in this course, you won't have to use the quadratic equation. Said another way, you can ignore X in this term.